Hi, I'm Joe, Kubernetes infrastructor to on-premises data centers. I was trying to come up with a sexier title for this, but it really is just that simple. So for context, I work at Giant Swarm. We are an infrastructure startup. So originally based in Cologne, and now a distributed team, so 20-odd people over 13 countries. And this isn't a sort of office with remotes. The entire team is distributed. We've been doing containers since early 2014. So originally a containers as a service product, and then transitioning two and a half years ago to Kubernetes as a service, when that became clear that that was the sort of orchestration system in the future. So we offer a product and a service together. It's not one or the other, it's the same unit. So the product itself is a control plane for managing Kubernetes clusters. So what that means is we have an API, you can create and you can delete Kubernetes clusters using that. And then there's also some management for key pairs and credentials and such. And then in terms of the services, we manage any cluster that you create. So we are like our customer's SRE team, I think is like our CTO's phrase for this. So that means that you create a cluster and we will take care of it. So if your API server is down or latency is high or your qubits are not ready, we get paged and we will fix this. That's on-premise, which is the sort of main part here, but also in the cloud. So for cloud, for us is AWS and Azure, with sort of Google and Alibaba sort of semi-roughly planned for the future, if people ask for it, basically. Customer-driven. I had this slide just in case, but I'm like 99% certain that everyone here knows what Kubernetes is, so I'm just going to skip over it. We talk about Kubernetes a lot today, so easy. Our control plane itself runs on Kubernetes. So if you saw our sort of Kubeception blog post, our API for creating Kubernetes runs on Kubernetes. In terms of on-prem, we actually then use that Kubernetes control plane to run pods, inside which are VMs, which we run the Kubernetes cluster in. And we find this quite useful because we wanted to use Kubernetes. It's a good product, why we want to use it, but also in terms of dog fooding. So because we run and we operate our own Kubernetes, we can then put that experience back to our customers. So when they ask us, oh, how should we run this? We can say, well, we did like this, and that's pretty useful. So the control plane, this is the Kubernetes infrastructure that the title references. So how we are deploying this to on-premise. And this consists of three things. And I wanted to sort of touch on what the actual workloads look like, so you kind of understood what we were deploying. So we have a microservices architecture in the control plane, and some sections of this are API services. And those together form the API that clients can use to set the sort of desired state of the system. So I want a cluster. I'm on AWS. Give me one. Then secondarily, we have operators. So following the sort of Koros operator pattern, not the framework, the pattern, these are going to see that desired state, so a sort of custom resource, and then move the actual state of systems towards that state. So in terms of AWS, for example, if you've asked for an AWS cluster, our AWS operator, which is fully open source, will see that you've asked for a cluster and then start creating CloudFormation stacks and KMS keys and such. Pavel and Ross are doing a workshop on Friday. They're over there. So if you want to learn how to do that, you can go there. And then also with infrastructure, so stability is actually even more than a requirement. It just has to happen. So we have monitoring on top to make sure that this is actually happening. So the simple stuff that your API servers are up, the latency is okay, the qubits are ready, but then also some more advanced features towards asserting the desired and actual state are the same. So if you've asked for a cluster with 5 workers, are there actually 5 workers? Stuff like this. So this is the infrastructure, the sort of control plane. This is what we're deploying. So about 2.5 years ago, I didn't check the date, but I think it's 2.5 years ago, we started building our Kubernetes as a service product, which is what we're selling today, and is our only product. And previously, our release engineering was very sort of manual and error-prone. So people would be building images. We had some tooling, but none of it was fully automated end-to-end. And when we were designing this product, we realized we'd have to sort of have lots of installations of this. We'd have to be able to manage it. We'd have to be able to deploy quickly and easily. So we made a conscious effort to improve our release engineering. This photo is when we went to Winterberg, which is a really nice Bavarian village, like in Germany. It's super lovely. So initially, I don't feel like I need to explain why CI is good, but just to be clear, first steps, we put everything into CI. So all our projects, we have one repository per project, just building it with CI. And that already starts advancing our development before we've even got to a sort of product that we're deploying. So we're sort of branching off from master. We test it with CI. If it's green, we can merge back in. And we've been doing this for years now. And it's really quite useful in terms of accelerating our development, because there's no more sort of, it looks good to me if it's tested or if it's built or if it's working. Like, we have that clearly. And because we're a distributed team, this is quite useful, because we have this visibility in our systems. So for context, we've been using Circle CI. We're a small team. We didn't really want to run our own build infra, and paying someone else to do it is quite useful. For context, Circle CI runs in AWS, so like US West and US East. And we'll sort of touch on this in a bit. And sort of early on, so 2 years ago, we were only targeting AWS as a target for our deployments, and also only actually supporting guest clusters on AWS. Now, obviously, this is advanced. We do Azure and we do on-prem, but at that point, just AWS, which makes deploying super easy if you're using Kubernetes. So at the end of our build step, after we've created our image, we had some directory that contained Kubernetes resources, so just some YAML files. And for all of our installations, we just loop over and run kubectl apply. And this gets you 99% of the way there, and it's pretty straightforward. And if we only did cloud, this would be the last slide, and this would be a really short talk. Except if your build servers, so some Circle CI instance running somewhere, can't reach your data centers. So this is probably about a year and a half later, a year and a half ago, maybe a year. We had a customer who was interested in running the Giant Swarm platform or stack on-premise. And they had, as a security requirement, so completely firewalled, that the control plane Kubernetes API server could not be accessible from the internet. And our build servers are on the internet, and they need to talk, and this doesn't work. So we were getting quite close to actually finishing this, and we needed a solution. Following on, we're now starting running Adidas clusters. So we run Adidas production. We're starting turning up clusters in China, and we've had like a whole myriad of network issues with them. So thankfully, we kind of preempted this a little bit. So we thought to ourselves, if we can't push from our build servers to our clusters, can we actually invert that dependency? So instead of the push, we actually pull from the data centers. So the idea here is that if we're pulling from some sort of well-known source, we don't need to have an endpoint exposed in the data center. So we sort of invert that relationship. And this is the sort of crux of how we're doing things nowadays. So we called it pull-based deployments as opposed to push-based deployments. And it's a catchy name, so I liked it. This is our old office in Cologne. So this is one of the few times we were actually like all in the actual office together. And I was trying to grow a Mohican, and it was awful. So we sat down, and we were like, what do we actually need to do? So boxing the problem instead of just going off and building something. And it was actually pretty simple when we sort of wrote it down. We wanted to support continuous deployment to cloud, which we were already doing, but we had this new requirement of also having on-prem, because we had customers on-prem. We didn't want to have some situation where, for us, on-prem was like a second-class citizen, because we believe very much in building software and then also running it. We also need to be able to deploy it on like a useful frequency. So going into a DC with a CD every 6 months, that's a very old way of working. We didn't want to do that. We also wanted to sort of box the problem, because release engineering tools are going to be a reification of your deployment process. So you have some deployment process that exists as like how we do things. And your deployment tools are just, you're writing that down, you're automating it. We reckoned we knew how to deploy to 100 installations, so control planes with associated guest clusters. But we couldn't foresee what that looks like when it's actually more like 1,000 or 10,000. So we thought, let's make sure we're not trying to build the system that Giant Swarm is using for the next 10 years. Let's build the one that we understand today. So 100 installations, that's the sort of rough target. And then we asked ourselves, now we know what we want to do, what do we think conceptually we need to make this work? One of these is wrong, and we'll see later which one it was. So we reckon we needed an actual package and a registry that we can keep the packages in. So instead of having some sort of homebrew directory with some Kubernetes resources that's super janky and we're the only people using it, we need an actual format that's open, and we can actually sort of use external tooling, and then a registry that we can keep those packages in. So instead of just pushing some random format, we're storing a format we understand, and we can pull that later. A communication channel. So clusters, we can tell them, you should install this software at this version now, or roll back, or roll forwards. And then also an agent. So conceptually, it's kind of like a spy. He's like inside the data center, and he's doing what we want. So we had some process listening on a communication channel, downloading packages from the registry, and installing them to the host cluster, or like the control plane. So pretty quickly, this was a really easy decision. We decided using Helm. So Helm is probably like the de facto Kubernetes application package managing format. It's basically just a directory that you store some resource channels in. So similar to what we already had, so there wasn't too much work there. But then also some work for metadata, for versioning and templating. And that was pretty cool. And this also allows us to use a lot of the open source tooling around this as well, like because we're adopting an open format. Around this time, Quay.io, so not from Chorus, from Red Hat, they'd announced the application registry and their work on like the APPR protocol. Application registry allows you to, it's like a Docker registry, but for charts instead of for images. So it has a very similar workflow that you can push a chart and you can pull a chart. And it's a pretty good tool, actually. And again, open formats. So we started building stuff. So we moved all our services, so one repository for each service, to have a Helm chart instead of this sort of semi-made-up format we had for ourselves. And this already gives us a benefit. Because we're open source by default, 99% of our repositories are open source. Anyone else can come and use Helm to install that straight away. So we'd create a chart on each commit. So we still are, tagging Docker images with the git commit char, because it's nice. That was a decision I just made. And then using that char inside the Helm chart, so templating that in. So our Helm charts are versioned with the git commit char, and they reference a versioned Docker image. And then we just keep pushing these up. And the communication channel, we decided on the GitHub API, so particularly the v3 deployment API. I'm just a big fan of this API, and I will talk lyrically about it forever. What it essentially is it allows you to create a deployment inside sort of GitHub, and then sort of have an integration with external deployment systems. It's a really nicely designed API. If you want to do this kind of, it's a deployment, there's some stuff moving on. I think GitHub like Heaven is quite a good example of this as well. So we also added support here. So whenever we merge to master, so we practice, if it's merged to master, it's everywhere, or gets deployed to all our installations. So we would create a Git deployment every time we merge to master. And specifically, so we have some number of installations that I'm not allowed to say. So we would create one deployment for each installation. So for example, with our AWS operator, so for turning up clusters on AWS, we have it statically configured in our CI system that the AWS operator goes to these installations. And we would create one deployment for each of those. This doesn't do anything yet. It's necessary for the later stages. And we also built Draftsmen, which is our cluster agent, or the process that runs inside the cluster and deals with all of this. If you remember the really hot summer in 2017, there were sort of 3 weeks of really crazy hacking to get this working. That was quite fun. This is open source. You can go and look at it now, and I think the design is like super good and modular. So if you have like other needs, you can kind of like poke it in and do stuff. So this is kind of how it works. I have a laser now, so I can like circle things. So this is kind of like two parts. Because with pull-based deployments, you have a difference between your actual build step and your deployment step. So it's fully automated, but they happen semi-asynchronously. So the left side, so everything here is the builds, and everything here is more control plane deployment. So the way this works is here, someone's writing some code, running some tests, E2E tests, all of this. A giant swarm engineer merges a PR into master. GitHub then triggers a build, bam, in Circle CI. Nothing here requires features of Circle CI. One of our sort of aims is not to be tied into any particular vendor. We use it pretty much entirely just to run jobs somewhere else. Circle CI runs, so we're very Golang heavy, so go test, go build, Docker build, then pushing the Docker image to Quay, and also pushing the Helm chart to Quay. So Quay supports both container registry and the application registry. We were already using Quay for our Docker images, so using it for our charts is pretty straightforward. And then at that point, the build is pretty much finished. We have charts, we have images built, we have binaries, and they're all somewhere else. And then our build tool running inside Circle will go, OK, this needs to be deployed here, 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 and create GitHub deployments. Separately, on the other side, so the right side, Draftsman is continuously polling the GitHub API particularly the V3 deployments and listing them. So it's asking, are there any deployments for any of the software projects I care about for my installation? So there are many of these, and we configure each Draftsman we call it the code name, and they're basically just cool animals. So Draftsman is asking, are there any deployment events for my installation? And because we've been creating them per installation, it only sees the one it cares about. So for us, installations have to be isolated. If it sees a deployment that it cares about, it will create a deployment status of pending. So we already have feedback that it started to take some work. It will download using Helm registry plugin, so part of the APPR protocol. From Quay, it fetches the Helm charts. It'll download that, and then using Helm, so again, using these open tools, which means we don't have to build stuff, via Tiller, which is like the sort of server-side component here, it'll install our resources in the Kubernetes API server. We call it G8 here because of like giant netties. It's kind of cool. After it's done that, it'll create another deployment status, normally of success, but sometimes not, and then we can sort of see this later. I'll go into that a little bit. So, for example, here, because we chose the GitHub deployment API, we have some really nice integrations with GitHub. So if you create a GitHub deployment referencing a SHA in a PR, it'll actually come up when you look at that PR. And again, we have this idea of visibility among a distributed team. So I can see pretty quickly that Roman, who's on my team, he's a nice guy, deployed to Gauss. So this is one of the code names. So like after Frederick Gauss, I think, an hour ago. And I have that visibility. I can see in the PR what's been going on. This is quite cool. And again, distributed team, or just any team, so we use Slack really heavily. So it also posts into Slack the Azure operator. So for turning up Kubernetes clusters on Azure, was just successfully deployed to Victory, which is one of our Azure control plane host clusters. And this is the SHA. He's also an old man, and I kind of like sort of humanizing our tools a little bit. So this has worked really well. It went into production in June 2017, and it's now May 2018, so just less than a year. And we've used this for over 25,000 deployments, which roughly, because I didn't really do a lot of math here, works out to 70 productions to deployment every day for the last year, on the average, which I'm super happy with. I'm really quite proud of that. That's a big number, and it's kind of hard to understand. So what that kind of means is there are two takeaways here. The first of all is the allowing us to scale. We wouldn't have been able to do 25,000 production deploys manually in a year with our team size. We would have had to hire people, and their job would have been, clicking through and following wiki pages, and that's not really worth it. We can now add new installations, and there's no need to grow the team particularly. In terms of operations, we have this, but in terms of releasing, not so much. And also, I think this is quite important. We're just saving human time. I don't want to do this job. I want a robot to do this job. The rest of the team, they don't want to do this job either. We've just saved a large amount of our own human time, which I think is something quite important. The other cool thing here is that this also means that it's 25,000 bug fixes and improvements and monitoring upgrades, and just overall improving the swarm globally. So one thing people ask us when they're like, well, I'm an enterprise. I can just hire 10 Kubernetes engineers, and we'll just run our own Kubernetes clusters. And yes, if you want to make that one of your core competencies, that is fine, and it's a good thing to do because it's open source and you have the freedom to do this. But we're running probably a scale of magnitude or two more clusters than you would be. And we can see problems. We have the monitoring and the expertise to actually then fix them across the swarm. So for example, a problem that one customer has will be fixed for all the other customers before they've even seen this. That's my favorite thing here. Like bug fixes just go out everywhere within a day, essentially. This is some random stuff I just want to talk about that is badly formatted. The GitHub API was an odd decision, I think, or had some drawbacks that I wanted to talk about a little bit. Having all the Draftsmen or our cluster agents repeatedly polling the API is a really good way to make your rate limits disappear. And when we started doing this, this was actually like a sort of concern for us. And we wanted to try and see if we could get it working. We can't use webhooks because we can't guarantee that a customer is fine with us just having some endpoint exposed to GitHub. It probably is technically easy, but like because of security and enterprise. Thankfully, actually no, then the important thing here as well, if you're just doing this in a sort of dumb way, the rate at which your rate limit is going to be decreasing is sort of related to the frequency at which you're requesting by the number of installations. So we have an issue here that the more installations we add, the faster our rate limit goes down, which I don't like. Thankfully, this is a really cool trick. GitHub has a feature in their API called conditional requests. So if you make a request to GitHub and it counts against your rate limit, they'll return a header of an e-tag header, which is some digest of the actual request body. And there is a request body here. This is taken just from the API documentation. I've just elided it for benefit. If you then make a subsequent request using if none match and then the e tag you got earlier, it's actually just caught by GitHub CDN. And it won't return if the data behind that URL, because it's kind of RESTful, hasn't changed. It'll just return a 304 not modified and not count against your rate limit. So this allows us to, because we're using the e tags and Draftsmen has support for this, we can just repeatedly poll the GitHub API and our rate limit doesn't go down at all. It will go down when we create a deployment. So the rate at which our rate limit is used up is related more to the number of installations by the number of deployments, which is way better because it means our rate limit goes down when we do work. It won't just be continuously being eaten up. This is really cool. I'm really happy with this. This is a great GitHub feature, so whoever built it is amazing. Then another issue we had with the GitHub API. So all our engineers are 24/7 are on call for sort of 24 hours. And one day I was on call for that day and was in the shower and got paged, which is like the worst situation for getting paged in because you are in a shower and your phone is not. So Draftsmen exposes Prometheus-style metrics for the amount of rate limit it has left. And I preemptively, thankfully, created an alert for this in Prometheus that if there's less than 10%, which is a nightmare situation for us, page. And I received pages from every single one of our installations in about a minute while in the shower, and it was the worst day. Until we realized that GitHub had just flagged our account. So GitHub has sort of inbuilt tools for flagging possibly malicious accounts. And this happened to us when I was apparently in the shower at 10 o'clock on a work day. So all the developers took the morning off, and I contacted GitHub support, and they were very sorry that this had happened. And we now have, a special note in our file that this won't happen again. This was the only major outage we've had for the last year in terms of our deployment infrastructure, and it was because GitHub was a little too aggressive on flagging, which I'm fine with. Also graphs. Graphs are useful for this kind of thing. And then also people ask me, but yeah, isn't GitHub just down sometimes? Yeah, they've moved to Kubernetes, so it's kind of better now. But occasionally, yes, GitHub is down, and at that point, we can't deploy. GitHub API stability is kind of okay nowadays, and if GitHub is down, then we can't write any code anyway, or push any code. So this was something we kind of went, fine. I'm going to talk about this a little bit later as well. We also have some nice features that enable us to do some additional sort of testing from this. The first of which is a feature branch deployment ability. Because we're pushing every image and chart on every commit, we have tooling that allows engineers to quickly deploy. So they create a GitHub deployment with their feature branch char and the code name of one of our test environments, which we maintain a few of across AWS, Azure, and on-prem. And then that deployment is noticed by that draftsman and installs their test version onto one of our test environments. And this happens within like a minute or two, which gives us a really good feedback cycle. So an engineer can push some code, try it out on an actual environment, as opposed to trying to like run it locally. We have full environments that you can test out like one particular thing and see how it acts. Because this is a distributed system, so as far as you can get with running locally, which is really annoying if you have to use like nested virtualization on OS X. This is even better. I was really happy with this. And also E2E testing. So our operators particularly, and also some of our operators libraries and some of our API services have full E2E suites. I mean, I feel like, again, I'm explaining testing to a crowd who understand testing. So what this allows us to do is, inside a CI build, we can spin up a test Kubernetes cluster, and then because we have these charts, we can just immediately install them for sort of any combination of test versions. We have a blog post about this coming out soon, sort of next couple of weeks, because I thought it was pretty cool. So yeah, what's going on in the future? This is more photos of us going skiing. Apparently people like playing the guitar. This is my friend Julian, and this is Ross. He's doing the workshop. So despite the fact I've been harping lyrically about Draftsmen for basically 30 minutes now, it does have some drawbacks and some stuff we'd like to address in the future. One thing in terms of features we'd like to do, so clusters that we bring up for our users, we are responsible for some applications inside there. So core DNS for DNS resolution, Nginx ingress controller for ingress control. We also have some tools for monitoring, so kubestate metrics and node exporter. These just come installed as default on giant swarm clusters because you need them, and it allows us to provide a better service. So right now we're using the K8 add-on script, which is a sort of bash script that loops over some files on disk and installs them onto the Kubernetes cluster. And that is kind of okay, but a little janky in terms of managing upgrades. So right now we either have to do it manually by sort of changing the files or rolling the entire cloud config on essentially the node, which just isn't good enough in terms of what we'd like to do. And also, if we're then doing applications in user clusters as opposed to just our control planes, the actual scale of the problem grows by like an order of magnitude. And as I said earlier, we sort of scoped Draftsmen to about 100 installations, and this starts breaking down a little bit. So we are building, and this is probably going to go into production for our users within a month or two, chart operator. So it's taking what we've learned from Draftsmen and building these kind of release engineering processes, and also what we've learned from building operators to sort of combine the two into a better release engineering solution. The inherent problem here is that our user clusters are dynamic. Our control planes are pretty static, like we know when we're creating them, and it takes a bit of time. But our dynamic clusters come up, come down whenever, and we don't want to have some registry across all our installations for which clusters exist. It's a bit too unified. These should exist separately. If we don't know which clusters exist, though, we can't actually use GitHub deployments because we don't have an environment to target. We don't have this code name. So that means no GitHub API, which actually, fine. We can live without it, and it removes a dependency or a risk from what we're doing. So it's an operator. So operators are essentially Kubernetes controllers that use the custom resource definitions. So we have a custom resource that defines a chart or something we'd like to install on a cluster. And this looks something like this. So it's essentially like any other Kubernetes resource. So this is just some example one. But the important takeaway here is the channel. So for example, you can define that I'd like to be on the stable channel and only receive upgrades that we consider fully stable. Or maybe you're a bit more brave and want to be on beta if you want to have like a pre-test or you need features from newer versions. So then we have the chart operator that also runs inside these user clusters. And that reconciles the installed release against the app registry channel. So this is, again, using that APPR open protocol. And the way this works is, so initially when you start up your cluster, you're going to have none of these things installed. You'll have the chart operator, and you'll have your chart configs, but that's it. So the chart operator will check against the app registry and see, no, sorry, it'll check against what you have installed, so using sort of Helm list. And it'll see there's nothing here, there's a chart, pull the latest one from the channel. And if then newer versions are updated, so added to the channel, it will install those and slowly reconcile you against your sort of desired state of being on the latest version for that channel. So yeah, this is the one we got wrong. You don't actually need a communication channel if your registry is storing the information you need. And actually, at a certain scale, the communication channel kind of breaks down a little bit. The really nice thing here is without GitHub, because I've crossed it out now, we have no hard dependencies for our deployment system. We depend on the APPR protocol, but that's open source. So if we ever need to, for example, change our registries, which we might need to for China, because like the Europe-China network thing is super weird, we can just spin up a new registry wherever we need to and use that. That's our only actual sort of dependency, which is pretty cool. I'm happy with that. And then also, we've moved the configuration over time here. So initially, when we've only deployed to clouds, all our configuration is in our CI. With the initial Draftsman-based pull-based deployments, some of the configuration is in CI. And now with child operator, all the configuration has moved to the user cluster, which is cool for two reasons. The first of which, for the users, all the control is on their side. If they want to change versions, they can just use kubectl edit on the custom resource. Or if they don't want that installed at all, they can just delete the chart config, and we'll remove that release, and it's fine. So for example, let's say you want to run your own ingress controllers. You can do that. It's fine. You have this control. It's your own vanilla Kubernetes cluster. And also in terms of information. So we're a distributed team, so we have to be quite transparent, and this also then becomes clear to our customers. This is how it works. You have the chart operator. You have this chart config. That's how that works. It's not some SRE like skulking in the middle of the night and fiddling things. It's very clear. And this is also very cool because it simplifies our CI/CD process. We don't have to create any GitHub deployments or do anything else apart from building and pushing images and charts. At that point, once we've done that, the user clusters will just reconcile themselves to the latest state. And we're also planning on transitioning the control plane, so our original sort of host clusters, to child operator. So eventually, all our clusters, wherever they are, will just be using child operator to slowly reconcile themselves, which I think is like perfect pull-based. And I think that's it.